Okay. Yeah.
Okay, so these are different libraries, and some are very important libraries, especially the scikit-learn. This library is about all machine learning algorithms. For example, whatever we will learn, so you can just import the model and you can use it. For example, decision tree, random forest, and SVM, regression models, all the algorithms. Okay,
Yeah.
so maybe I have checked that they have also added some code in these slides. So maybe if we will get time, I can also teach you like how to run and those things. Okay, so because you know some libraries, so I think it will be easy for you. Then next is NumPy and Pandas. NumPy is about numerical Python. It's about linear algebra. For example, if you have equations, arrays, and matrix, so you can use NumPy. And Pandas is the advanced form. It's like you can read some CSV files or Excel files, those things. So all the data processing are with the Pandas. Okay. Next one is the TensorFlow. So if you want to work on deep learning, so TensorFlow and PyTorch. This PyTorch is from Facebook. Okay, these libraries, and this TensorFlow is from Google. Okay, so you can use this library or this library, and this Keras is like the high level wrapper of this TensorFlow. Okay, so these two are from Google, and this one is from Facebook. So you can use any library. For example, maybe in future, if because I check your course content, they didn't add deep learning lectures about, like, for example, CNN, RNN, LSTM. So maybe you will not use these libraries for now. Okay, and but yes,
Yeah.
we have choose a little, so your work can only be completed by these libraries. Next one is OpenCV, and it's about working with images, as you discussed about computer vision. So maybe we will also use. Okay, and about some other libraries which are important, like Matplotlib. Okay, Matplotlib is about the plotting. You want to plot something, figures and the graphs and those things, so you can use that library. And its advanced form is Seaboard and Plotly. Those libraries, maybe in future we can also check how to use those libraries to make some interactive graphs. Interactive graph means when you will take the mouse on that, so in this way you can just check the values at that place. So, but for the now, because they have just discussed scikit-learn, it's about the machine learning models. NumPy is for the numerical Python, like equations, arrays, linked lists, something like those. Pandas is for like some data processing, and these are important for you. You can skip these one for now. Okay. So, any question here?
Okay. No, thank you.
Okay, so next is why it's important. We know that four are basic things which are important for machine learning. Algebra, it's same about NumPy. Most of the algebra is in that library. So you can like how to represent and manipulate data. So that one algebra, like, because most of the things are in matrices like images and the graphs and those things. So matrices are important. So equations and 2D equation like matrices are from the algebra part. Then we have the statistics about, like, we want to find mean, median, mode, and like we want to describe the data. We want to know how many rows, how many columns. Those all things are from statistics part. So we want to extract the meaning from data. So this one
Yeah.
is statistics. So basically there are two kinds of statistics. One is descriptive statistics, one is inferential statistics. So we will not go to the detail now, but descriptive statistics is about to describe the data, whatever the data is, like how many, what is the median of column and mode or whatever. And inferential statistics about, like, we have to predict something and we want to generalize. Then we have the probability. Probability is about we have some like uncertainty. Uncertainty is like we want to make decision. For example, we can say 30% probability is this one and 70% is class 2. So if we have different classes, then we have to tell what is the probability of class 1 and what is the probability of class 2. So probability is also important for the machine learning. Next is calculus. Calculus, we know that it's about optimization. So when we will talk about gradient descent and about the mean square error, then optimization, we will talk about this. So calculus part is about the derivation, about like partial derivatives, and finding the optimal value. These things we have to find the maxima and minima from these calculus part. So to improve the performance, we need the calculus part. So I hope it's easy. Any question?
So to improve the performance of the algorithm, we have to do optimization, right?
Yes, right. So basically,
Okay.
when we will have some algorithm, we have to do some training. And during the training, we have to improve we have to check like how much trained we are now. So we have to improve the performance based on the using some gradient descent algorithms, which is a one optimizer way. So we have different ways we will discuss, and then all these things, derivation, partial derivation, it's from the calculus. So it means they are just talking about you should know basic algebra, you should know statistics, you should know probability and calculus to work on machine learning.
Okay.
Great. So no, not important. It's about, I think your Neom city is very famous now. So they are talking
Yeah.
about they will have some robots and a lot of things there, and all AI will be there. So they said that artificial intelligence will be the backbone of the city. So
Mhm.
we are talking about the lecture one intro. So I think these are just applications, and I will just go very quickly. And if you find some problem, you can just stop me. And
Okay.
machine learning in everyday life, we know that search engines are using machine learning. You use machine learning every day when you run a search engine query. So we know that here they are using to find the next word. So this is also like the natural language processing part, where we have to find the next word, which can be the next word, and what will be the probability. So based on the probability and based on the search, they show the next word and the possible words, so that the user can just select from the drop down. So this is machine learning here. This is personal assistant. As we know that like Siri is one example, Apple Siri. Which phone you have?
Mhm. I have Siri.
Okay, you have Siri. So you know what is
Mhm.
this. So I think it's okay. So basically speech recognition and question answering, and these are some examples of machine learning. So next one is spam and fraud detection. For example, we have emails and we have to find which email is spam and which is not. So this is another example of machine learning. Next one is self-driving car. So we have to find the different objects through computer vision, and then you have to find the like which car is moving and what is inside, what is the signal, what is like all the things. You have to find the objects through some computer vision techniques, and all the computer vision is based on machine learning and deep learning techniques. So basically you are using computer vision, you're using machine learning and deep learning algorithms to perform these kind of tasks. So what is machine learning? The subfield of computer science that gives computers the ability to learn without being explicitly programmed. So we don't have to apply the if else conditions. You have to just like you can say if an algorithm learned by himself, learned by itself, and you don't have to give the rules to them, to the algorithm, then you can say that the algorithm is intelligent. So that is like a machine learning algorithm. And what does learn and explicitly program mean here? Let's look at example. So here they have talked about the example, how can we solve a specific problem? As computer scientists, we write a program that encodes a set of rules that are useful to solve the problem. So if you can see that if we want to just make a program for pass and fail, so we can do this kind of program, if condition and else condition. Okay, so in this condition, there is no learning. You can say we have a if else condition, there is a algorithm, and you can just say that okay, whatever the condition will be true, it will be printed that condition. So in this case, it's a simple program. There is no learning in this program. But
Yeah.
in this case, how can we solve a specific problem? For example, if we have different type of cats, so we cannot do like as previously, we cannot define the specific rules. So in many cases, it's very difficult to specify those rules as we previously defined, like the pass and fail. So given a particular, like given a picture, determine whether there is a cat in the image or not. So these are different type of cats, and you can see with different poses. And this one is like the downside. So
Up and down.
yeah, you can see that how we can define the rule. It's very difficult. Okay,
I
so
think it's complicated.
yeah, it's very complicated. So here we can say that we cannot define the rules, and if we find the edges and those things, it's too difficult. So Heba, you are learning computer vision also in this semester?
Yes. Yeah.
So how good you are learning?
What?
I mean, do you think it's easy, computer vision, or no?
Computer vision. Actually, sometimes I think it's hard. Sometimes I think it's easy. For example, when we apply the filters, median filter, average filter, and also Gaussian filter, it's a little.
Okay, so if you need help, you can let me know.
Yeah, of course.
Okay, so in many cases it's difficult. So okay, next is self-driving car. A self-driving car system uses dozens of components that include detection of cars, pedestrians, and other objects. So we have to detect these objects, all the objects, like this is tree, this is person on the bicycle, and like these different cars. So it's so difficult to define the rules and just do some specific things. So machine learning is really required. So here they said that they are trying to make a rule-based algorithm. One way to build a detection system is to write down rules. So they make some rules. I think no need to discuss the code. Or you want?
I can understand, it's easy code.
Yeah, okay. So they just like camera dot get object, and if they have wheels, then if the wheels are forged, you can say it's car. If like the scene from back, okay, the object. So these are like two wheels from downside. So the back side, so it means that it's again car. Otherwise, it's bicycle. So it's like but you can say that it's not so easy to define only based on these rules. So how we will find this is a wheel or not? So first we have to you have to match the wheel, how many wheels, and how you can find that it's a wheel or some, you can say it's some person or maybe apple or whatever in front of you. So again you have to find something. So it's not an easy task to do based on the edges. So in particular, it's important, it's almost possible for a human to specify all the edge cases. Then they said that okay, ML machine learning approach is much better. The machine learning approach is teach computer how to do detection by showing it many examples of different objects. Okay, so here you can see that they have found different objects, and they know that what is this one, pedestrian or vehicle or what. So no manual programming is needed. The computer learns what defines a pedestrian or a car on its own. So how they define, how the machine learning works, we will discuss. It's another example takes that requires a task that requires machine learning, like what makes a tool. So you can see that they have discussed different like this is handwritten digits and we have to define based on the algorithms. So what is machine learning? These are some definitions. Machine learning as a set of methods that can automatically detect patterns in data. So this is important, automatically detect patterns in data and then use the uncovered patterns to predict future data. So these are like, first we have to train, then you have to uncover the patterns and to perform other kinds of decision making. So this is one definition. Second one is machine learning, a branch of AI, is concerned with computer programs that automatically improve their performance through experience. So based on more training, more and more training, they have to improve their performance, like apply some training, some validation and those things. Other definitions, a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task in T as measured by P improved with experience E. So it's like a pure definition, or you can say technical definition of AI, the machine learning, you can say, which is given by John Mitchell in 1997. They actually talking about like they should have experience based on the task, and we have to measure the performance P. So as an example, they have like, suppose we feed a learning algorithm a lot of historical weather data and have it learn to predict weather. So like they have the weather data and they have to predict the weather for future. So they are talking about what is T, what is P, and what is E. So we know what is our task. Task is to predict the weather. Okay, so this is our task. This is our goal. And what is performance?
So the weather prediction is the task.
Yeah, weather prediction is the task. And the performance is the probability of it correctly predicting a future date weather. Okay, so like we have to check the performance based on how accurately they are calculating the predicting the weather. If the weather prediction is very accurate, then the performance will be high. Otherwise, the performance will be low. And experience, it's the process in which we learn how to predict the data. So the process of the algorithm examine a large amount of historical weather data. Like they have the data, previous data, and they have to learn from that data. They have to examine the data. They have to find the patterns, and that whole process is called experience. Based on the experience, based on the examining the data, they have to improve the performance. And after improving the performance, they given a task to predict, and if the accurate prediction, then we can say the performance is improved. Okay, so any question till here?
So to check if I understand, so here in this question, the task is to predict the weather. And P is the probability if the prediction of the future is correct or not. Yeah, but here I can see future dates.
Future dates, yes, because we have to predict the future. You know, we have to tell about like tomorrow weather. Okay, so how we can tell about tomorrow weather? If we can tell that this will be the temperature, this will be the outlook, this will be the humidity, then what will be the weather? Will it be raining or not? So in that case, this is the prediction of the future weather.
Yeah, so so B is to check if the prediction is correct or not.
Yes, performance. We have to check
and
the
and E is the process to see how to learn this this method, right?
Exactly, yeah. They have to analyze all the data, whatever previous data they have, and they have to examine the previous data and to learn from some that thing. And the learning process is the experience. Like we want to say, they say why you are going to USA. They want to say like I want to experience, like I want to learn new things. I want to explore the things. So this is like the experience. So based on the data, you have to learn, you have to experience more things. Okay, for example, if I say I want to predict about if a person have brain tumor or not. So in this case, what will be G, what will be P, what will be?
Yeah.
You have to tell. Like we want to predict if a person has brain tumor or not.
Yeah. And also, I've seen an example if we want to predict the price of the home.
So in that case,
yeah,
for example, price of the home. So the task is to find the to predict the price.
Whether.
Okay.
Yeah.
Yeah. In that case, if for example we have example of we want to find the price of the house. In that case, what will be the task? Task will be the prediction of the price of the house. Okay.
Okay.
And what will be the performance? Performance will be like how accurately they predict the price of the house. And experience is like they have to give some previous data. Based on that data, they have to make a classifier. They have to examine the data, and then they have to make the training. So training process is experience, and testing process is the performance. Based on the testing, we can say that how accurate is that. So the performance is that, the probability. Okay.
You know, doctor, I was having a problem to understand what is the difference between training set and data set.
Training set and data set. So data set is the bigger one. Whatever they will give you, that is the data set. For example, it can be any. Like for example, if we want to predict that what will be the sale of the Amazon tomorrow. So they will give us the data of previous 1 year, for example, that we have sale these things. Amazon will give us the data set, and they will tell us, okay, we have these things every day. So in that case, the data set is actually the all the data. So what we actually do, we divide the data set into two parts. One is called a training data set. One is the testing data set. What is the training data set? Training we use to experience. Okay. For the training, we try to train the data set, and the testing data set, we have to find that how good we have trained. And in that case, we have to find the performance, or we have to find that how much is the accuracy. For that purpose, we divide the data set into two parts. One is training data set, one is testing data set. Normally, what we do, we normally do it like 20 and 80%. So for example, if we have the 100 objects or the 100 rows, so we normally divide it into 80 rows for training data set and 20 rows for testing data set. So the training data set will be used for training, and testing data set will be used for we want to confirm that how much best or how much accurate is our trained algorithm. So when we will come to that one, then I will give you many examples that how we will split the data set into two parts and why we actually split. So the whole data set, for now you can only know about this thing. The whole data set is data set. We divide it into two parts. One is for training, one is for testing. Training will be used for the training. Testing will be used for to check the performance of the algorithm, whatever we have trained, to check the performance of the model. Is it okay? Are still confused?
Yes. Yeah. But doctor, I have a question. So first we have to train our data, and then we have to test, right?
Yes.
Is it correct? Like this?
Yeah, correct. So basically, if you see, for example, I can give you example. For example, there is a small boy and he asks you 10 questions. Okay, so 10 questions is like he asks you, what is this? And his finger is pointing towards fan. You tell him that this is a fan. Then he asks you again about something. You say this is a chair, this is a table, this is something. Okay, so this is the training of that person, or that kid, that boy. And after that, you ask some question to him. Okay, like for example, you ask, okay, now tell me what is this. If for example he say correctly, so it means that you can say he is correctly trained. Okay, so otherwise, if his accuracy is not correct, so you can say that performance is bad. So how, which part you will use for the training? It's the training data set, and the questions which you will use for testing, that is called the testing data set. So when we will have some data set, I will explain this to you again.
Okay.
So what is the difference between traditional programming and ML? So traditional programming is like we have rules, we know like if else conditions, and we have the data. So according to that condition, for example, there is a one person and they say if the marks is greater than 70%, he's pass, otherwise fail. This is a rule. And we have the data, and the data is like there is a person, the girl is Eva, and her marks is 90%. So this is data, and we will give the data to rules, and we check that okay, marks is greater than 70, yes, this 90%. So according to the rules, the answer is yes, he is passed. Okay, so this is the rules. This is the you can say traditional programming, and the machine learning is different. We have to give the answer and data. Why we are giving the answer? Like this is the training process. We have to train. We have to give the label. We can say okay, this is a car, this is apple, this is a fan, this is something. So answer is there. Then we also have the data like fan, apple, something. Then we have to make the rules according to based on the machine learning algorithm. We have to say okay, if the shape is like this, the color is like this, so this will be the. So we are making the rules in this case. So we will only give the answer like some training data and the data. So in that case, we will make the rules, and this is called machine learning. So I hope it's a little easy.
Yeah, it's very easy.
Okay. So more examples of machine learning example, you know, credit scoring. I think it's easy. We can just skip. Okay. Or you need.
Yeah. I think applications, it's easy, doctor.
Yeah. So credit scoring, it's like we have to find that we have to give that person loan or not. Yeah, or he will pay back or not. So based on some his income, savings, collaterals, profession, age, past financial history. Based on this, we can predict that we have to give him the loan or not. So credit scoring is like one part. Second is like pattern recognition, like we have to recognize the face. This is another example. And third one is like optical character recognition. We have to find the numbers. Okay, so based on that, to recognize the character is another example. In medical applications, we have to diagnose a disease as we discussed. we have some symptoms, we have lab measurements, test result, DNA test, and output is like one of set of possible disease or none of the above. So, for example, if someone say I have blood pressure of this, I have diabetes, and I have this test result, my this result is positive, this is negative. So, do I have this disease or not? So this is like the we have to train and then test. So this is another example. We can just using algorithm, we can say this person had disease or not based on his symptoms. And next one is like recommender system. It's like the YouTube and Netflix. So if we use, if we watch some movie or on YouTube or Netflix, so according to our previous history, our previous experience, they give us the more examples or more recommendations. So this is another example. Market basket analysis is like unsupervised learning. It's like we have, like for example, if a person is buying the bread, so maybe he will also buy the butter, and he will also buy the milk, maybe jam. So these like
priori, doctor, right?
Hmm?
It's a priori algorithm, right?
Yeah, it's true. A priori algorithm. So this is like this. Yeah, that is one algorithm. Based on the a priori algorithm, we can do this market basket analysis.
Yeah.
Next is like fraud detection. This is same, like we can check the credit history of that person, and then we can find who is doing fraud. Telecommunication, like spam filters in emails, and intrusion detection is like in the network we want to find there is some intruder or not on, there is some phishing, there is some like virus. Some we can also detect those things based on machine learning algorithms. So why machine learning? We know that it allows building practical systems for real world applications that couldn't be resolved otherwise. Okay, so we have some values here and we can just do this. And in this way, like a person who have to do it by manually, so we can make it automatic. So discover new knowledge from large data sets, like this is called data mining. So we can find the patterns between the data by using the machine learning. Next, develop systems that can automatically adopt and customize themselves to individual users. So like personalized news and email filters, something like this. And it's like ability to mimic human and replace certain boring tasks which require some intelligence, like recognizing handwritten characters. So for example, there is a book and it's handwritten, some notebook. So if you can recognize these kind of characters, so we can just make it, this is an application, like we can just take the picture and your algorithm can recognize what is written, the characters and digits, and they can give you the values. So in this way, you can make all the paper books to the digital form without the data entry operators. So this is like the automated automation we can also do by machine learning.
Yeah.
So any question till here?
No, it's clear now.
Great. Oh, why ML now? So we know that there are a lot of data, like flood of available data, especially with the advent of the internet. So we have internet. We know that data is coming from all places. We have social network, we have the CCTV cameras, we have YouTube, we have the internet. So like we have network data, we have websites. So a lot of data we have. So data is coming, and our computational power is also increasing. We know that we have GPUs and TPUs, and so these, based on these, we can, our computational power is increasing. So if our power of the processors is increasing and we have a lot of data, so we also have many effective and efficient algorithms. So of course we can do a lot of things. We can automate our world. We can make the planes automatic. We can make automatic cars, a lot of things. So that's why they say ML is very important, because all the artificial intelligence, in artificial intelligence we say okay, like the person or robot will do this, all the robot will do this. So but how he will do this, all behind is that some machine learning algorithms. If we want to recognize something, if we want to understand the voice, if we want to translate, if we want to know what is written inside, if we want to know that the person behind in front of robot is enemy or a friend, they have to hit him or they have to hug him. So all the things are based on the recognition, and we have to train our robot, and all the training is based on the machine learning algorithm.
Machine learning, yes.
So it means that machine learning is very important to make the word intelligent, to make the robot intelligent, to make the software intelligent, to make the algorithm intelligent. So all these are based on the machine learning. So if even if you are working on computer vision, if you are working on natural language processing, if you are working on data mining, if you are working on pattern recognition, if you are working data science, all the fields, whatever you want to apply the intelligence in any place, you have to learn the machine learning and deep learning algorithms, because behind the scene all these algorithms are working. So if you know the algorithms, then you can do all these things. So there are a lot of fields of AI, like computer vision, pattern recognition, natural language processing, data mining, data science, all the things. So these all fields are incomplete without machine learning. So I hope you understood why
Yeah.
we are learning machine
Yeah, everything is clear, Doctor.
learning. Okay, so machine learning tasks, we have 4 types. Normally they say 3 types, but there they have also added 4 types, like the semi-supervised. So normally it's supervised learning, unsupervised learning, and reinforcement learning. So they have talked about another like semi-supervised learning. So if we have the label data, okay, we have data to train, then it will be supervised learning. It's called like supervised. So we have, like, we can supervise, we can train, we have a teacher to, we have supervisor to do some supervision. So if we don't have the labeled data, then we will apply some unsupervised learning. So we will just find the similarity and we will find the patterns, those things. So it will apply the unsupervised. If we have the,
Mhm.
some part is we have labeled and some data we don't have labeled. So we can apply semi-supervised. Semi-supervised means some part is supervised, some part is unsupervised. Somewhere we have label, somewhere we don't have label. So that's why we apply semi-supervised learning. And the fourth one is reinforcement learning. So if we have the, like we have games, we have the self-driving cars and those things. So if we have to find, like, do something, we have to learn, we have to train our algorithm based on punishment and reward. For example, if we go to the right side, if we go to towards the object or towards the goal, then we can say we will reward him. So that algorithm will know, like, okay, I am going on the right side. But if he will going on the wrong side, we will punish him. So based on the punishment, he will know, like, okay, I don't have to go to that side. So reinforcement, enforced learning, enforce mean we are forcing the learning, we are forcing that what he have to do. Okay, reinforcement, we are forcing him again and again. So if we are forcing him based on punishment and reward, that is called reinforcement. Okay.
So Doctor, reinforcement, for example, a self-driven car, it's going to let the car to decide which, for example, if it has any action or event, so the car, the car would decide by itself in which, for example, in which path it's going to be with him, for example, to the right or to the
Yes.
left.
Mhm.
Yeah.
So in
Yeah.
that
So
case,
this is
if the side is correct, for example, maybe he decide to go and hit something. So if he will hit something, or maybe on the right side there is a footpath, and if he go to the footpath, so it means we have to punish him. So in that case, the
yeah.
car algorithm will learn that no, next time I don't have to go to that side. So based on the punishment and based on the reward, the car is learning, and based on that learning, we are giving him punishment and we are giving him the reward points. Based on that, he is improving its driving by himself, by itself. Okay, so this is a way.
Yeah.
Okay. So it's behaving like agent. So agents are like, we have a game. In the game, we have an agent. So if the agent is going correct, so we will make the number high. Okay, so he will improve. But if he will hit something, some boy, someone, and in the game he is not working correctly, so maybe we will decrease his points. So in that case, he will also learn. So this is like different examples. Maybe we will get more examples with the time.
Yeah.
Okay, so uh,
So, Doctor, please, last question.
yes,
Reinforcement, here it depends on hardware and software. So hardware is the agents.
yes,
For example, I have seen Mercedes last version of cars. When the car see any object in front, it's going to stop.
yes,
So this is example of reinforcement, right?
yeah. It's example of reinforcement, but they already trained. You know, it's like they already trained based on the that during the training process, it's called reinforcement learning. But yes, that was trained by using reinforcement learning.
Yeah.
Okay,
So
so
I understand. Thank
yeah,
you.
so there are like hardware and software, but hardware is only for the sensors. Okay, like sensors and
Yeah.
actuators. For example, if we have a camera in front of the car, so they are taking the picture, and from those pictures, there is some machine learning algorithm which is working and finding the objects, detecting what is in front of that, and all that part is again machine learning. So algorithm is all the things, but the
Yeah.
how to say, the hardware is only to, like wheels, they will only the actuators, like they will perform action based on the software. Software will tell them, okay, from the sensors they will get the data, and from the actuators they will say, okay, perform this action, maybe move right, move the left, and go straight, something like this. So you have to understand, like main thing is we apply machine learning on the software, and hardware is just to sense the data and to perform the action.
Yeah.
Okay.
Thank you, Doctor.
Any other question?
No, thank you.
So it's enough for today, or you want to learn more?
It's up to you, Doctor. I don't mind.
Okay, so maybe we can have 1 hour class next 4 days. Okay, and we will, or we can complete this one. Okay.
Okay.
Okay. So supervised learning, the most common approach to machine learning is supervised learning. It's like, as I already told you, we have the labeled data in this case. This is very common. So first, we collect a data set of labeled training sample. What is labeled here? Labeled is like label. For example, this is dog, so this is label. Okay, this is dog, this is again label. So we are making label, we are tagging each image with some label. We are giving the tags like this is dog here, this is dog, this is cat, this is dog, this is cat, something like. So we are tagging or labeling the all the images. So we collect the data set of labeled training example. So because we have the label here, so this is our first task. Second, we train a model to output accurate prediction of this data set. So we are training. Next part is based on these labels, we have to train the data set, or we have to train the model. That will be some supervised learning model. And the third part is testing. Because we have already trained, now we have to test, we have to check the performance, we have to check how much they have already trained. Okay, so how we can test? So we will use the test data here. When the model sees new similar data, it will also be accurate. Like it should actually find, for example, if this figure comes, so it should know that this is cat. So if we have a data set, as we know, we will have a data set here. Some data set we will use as training to train the model, and 20% of the data set we can use as testing to find how much accurately they have learned. Okay.
Yeah. But doctor, I have a question here. For example, here, if we see the photo of the dog and the photo of the cat, of course, there will be a lot of differences. So if we divide the data into training set and data set, I think, how could the machine or how could the model learn from this? Because there is a lot of differences between eyes, the space between eyes, the nose and mouth and ears.
Yes, actually, this is the whole part of computer vision. How we actually, maybe you know about, for example, we have an image, and image is actually a 2D array of pixels, matrix of pixels.
Yes.
So based on those pixels, we actually, if we talk about this is a colored image, but if we convert it into grayscale image, all the values will be from 0 to 255. So those values from 0 is like black pixel, and 255 is like the white pixel. So all these values will be between 0s to 255, and based on those pixels we have to find the edges. First we have to find the edges, and then we will convert those edges to the shapes, and then based on those shapes we will apply some machine learning algorithm to train our model. Okay, like if the eye will be like this, will be actually, what is eye? Eye is actually, there is some shape of this. If shape is like this, the circle, maybe they can say this is the eye of a dog. Okay, so if the eye is like this, so we can say, okay, this is, so all these are based on the pixels of those images. So we have to calculate the edges, we have to calculate the shapes, and based on those shapes we can detect that if it is a cat or dog. So this is mainly an example of computer vision. But of course, we will apply, for example, on the weather data set, we can apply the same concept, and we can apply on the humor data set, we can apply on the fishing data set. So it depends on the data set. If, for example, we have a voice, and from the voice we have to recognize who is the person. So that's, and again, natural language processing field. So there are different fields which we will use maybe in future to understand, like what will be the label and what will be the training, how we will do the training. So how we will do the training, that part will be, there are a lot of algorithms, and every algorithm tell a different way of training. So if we learn about how to train, maybe you will tell a new way of learning, a new way of training. So it means you are proposing a new machine learning algorithm to train. And how good you have trained, how good is your model, that will be decided by the test data. So they will give you some, for example, if you give the guy, as I told you, that if a person, you teach a boy, like you have teach him, this is this, and this is cat, this is dog, and then you ask a question, and if he replies you correctly, you can say, yes, now he is well trained person, he knows what it is, so he tells you all the correct answers. So this is the same thing. You will train something based on the images, based on the data, based on the training data, and then you have to find how much accurate he is trained, how accurately that model is trained. So this is like machine learning way. So you will separate the data set into training, testing, and all this. Okay. Any other question?
Okay, Doctor. No, thank you. It's clear.
Great. So next is consider a simple data set for supervised learning. Okay, house prices in Boston. So this is another example. Like we, for example, if we go to property dealer, do you know property dealer?
What?
Property dealer.
What is this?
I don't know, in your country it's not like Property dealer is like who actually, when you want to sell your house or when you want to buy a
Mm-hmm.
new house. So if you want to sell your house, so some persons are behaving like property. They actually deal with the property. So they will come to you, they will check, okay, this house, your house has 5 bedrooms, 5 washrooms, and 2 kitchens,
Oh, yeah.
these floors,
The
and
component of home.
yeah, exactly. So they will tell you,
Mm-hmm.
okay, based on your quality, based on the number of rooms, based on the furnishing, based on the quality of your home, the price is like this one. Okay, maybe the
Yes.
price is like 5 million based on the according to your home condition. So you can say, okay, so this is the condition. So what they actually check? They actually check the location. Maybe if the house is in Riyadh, then the price will be very high. But if it's on the border something, maybe the price will be very low. And same like if the house is in the village, the price will be low. If the house is in the downtown of the city, a big city, then the price will be high. Same like if the house is more floors, many floors, so it will be high. But if the like only single floor, single story building, then it will be the low price. So a lot of things, the
Yeah.
area of the house, the number of rooms, the quality of the room, something like this. So all these things we are supervising the data. So if, for example, how they actually check and how they make the price, those guys are the companies. So we actually trained our model based on the values, and we tell, okay, if the number of houses will be like this, the price this, and the neighborhood will be this, the area will be this, and location will be this, so price will be this. Okay, so based on these things, we have trained our model, and after that we will ask him our model, okay, if the quality will be this, the model will be this, the house will be this, the number of bedroom will be so much, something like this, so what should be the price? So if your algorithm will tell you the exact price, so you can say your algorithm is trained very accurately. But if your algorithm is giving the bad price, not accurate price, you can say no, your algorithm is the bad one. So they actually didn't train well on the data. So this is actually a way. So you have to supervise your model based on the labeled data. So I hope you understood.
Doctor, last time the doctor said the accuracy of the algorithm depends on the quality of data. If it gives me a good result, the quality of data is good.
Yeah, actually,
Otherwise, it's not.
yeah, actually, a lot of things matters. If the quality of the data, number two, the algorithm, okay, like the quality of the algorithm. If your data is wrong, of course, what how accurate is your algorithm, your result will be wrong. It's same like, for example, if some person asks you what is this, and he is pointing towards the apple, and you tell him that it is a fan, so you actually feed the data wrongly to that person. Okay, so if you give the wrongly, you have make the wrong answers. So the boy, he doesn't know. He's the new guy. So whatever you will tell him, he will learn according to that. So next time, whenever he will see a fan, he will say, "Oh, this is an apple." But actually, the the error is not on the, the mistake is not on the boy side. This is the mistake of that guy who told him the wrong thing. Did you understand?
Yeah.
Yeah, so it's all depends that whatever, like for example, the court say the human or person don't have a problem, the society gave him the bad things, that why his education and his quality of the learning discipline, these are not good. So in the same way, if our data is not good, so our algorithm can't do anything, of course the result will be wrong. So our data should be correct, and second thing is our algorithm should be very efficient. So in both cases,
Yeah.
then we can get the good result. If our algorithm is bad and data is correct, again it's the wrong answer. If the data is wrong and algorithm is good, again it's wrong answer. So data should be good, algorithm should be good, then our result will be good.
Yes.
Okay. So yeah, this is the, if you want to have, there are many data sets already. So you can just use like sklearn. You know, we have discussed the library here. This one, scikit-learn. Here, this is library scikit-learn. So this library sci, s and it k and learn. So if you want to use in Python, this library you can just say sklearn. So this library they have used here. Okay, here. So you can say from sklearn, they have import data sets. So there are a lot of data sets already exist in this library. So you can just load any data set. So they have loaded the Boston data set and they will do something with this data set. Okay. So
Yes.
we will visualize two variables in this data set, house price and the education level in the neighborhood. So can you understand this one?
Yes, I can understand. Here, they have been importing a matplotlib library.
Yes.
They plot as a model, name of the model is PLT. And here, they've been deciding, they've been using
actually, they are not giving the name. It's just like you can put anything here. It's just like a small form, PLT. So if you,
yeah, but
you can just say P, C, B, whatever you want, ABC. So then you have to call ABC dot something like this. Okay.
Yeah, so we may say here as, for example, as any name, PLT or anything else, this is the name of the model that we can use later,
okay.
Right? Yeah, so here 12 and 4 is the size of the image.
Great.
And here the type of chart is scatter. Yeah, here they've been using the dataset name Boston data. They've been 12 datasets from 0 to 12, right?
No, this one is the rows here. So when he just put the column here, it means they are using all the objects are rows here. Okay, but 12 is that this is the 12th column. Okay, so the column number is 12 is using, but all the objects in that column they are using. So you can just, okay, the Boston dot target he is using here.
So doctor, what does that mean, target?
Target is like
target
is the labeled, you can say that class, target variable. It's like, for example, okay, so target variable, what is the target variable? I think price. Yeah, this price will be the target variable here, which is called Y label. Okay, so Y label, the Y side is giving the target label, the price is target label, and number of adults in neighborhood. So on the 12th variable is the number of adults. So this is the 12th variable. You can just change this variable here, and then you will know that you can also make this plot based on the different variables. So what he is doing, he is just using that 12th variable and he is comparing it with the price. Okay, so based on the price target variable is the price. The price is the target variable. Okay, so because target variable is like what you want to find. Here we want to find the price of the house. So this is target variable. So
we may say target is a goal.
Target is the goal. We have to find the price.
Yes. Find the price. Okay. Find the price.
Next.
Yes, next.
Here, Y label. What is Y label?
Yeah, Y label here on the graph, as we can see here in the Y label. It's for example, like in C#, read line, write line, like this. So here we've named the Y label on the graph. As we can see here, median house price.
Yeah, so Y label will come on the Y side. You know, we have X and Y column. Sorry. X and Y
Yes, we
column.
have.
So this is the X side.
Yes.
So X label will be the horizontal, this one here, and Y label will be
Yes.
here on the Y
Is
side.
the vertical.
Yeah, vertical.
Yes.
So vertical
And also
side,
the title.
the title will come.
The title. Yeah.
Okay. Yeah, it's easy. Okay. So this is the way to show
It's
a
easy.
graph. Okay, great. Next is a supervised learning algorithm. We can use this data set of examples to fit a supervised learning model. Okay. So we can have the model input. Input is, it's normally labeled as X and the output as Y. So output is same as target. Okay, so we also call the output as target variable. We call it as the dependent variable. We can also say is at output variable. Okay, so we can give any name. And the X1 is called input variable or independent variable. Okay, so this is like the predictors. So these are different names. Maybe I will write and then I will send you like how can you call the X variables? There are different names. Okay. So he is just use X as the education level and Y as the price of the house. So Y is the target variable or output variable. X is the input variable. So he is comparing these two with this. So it learns the mapping from our data set of example XY. So we will have a mapping between the independent or input variable and output variable.
So doctor, we may say X is dependent and Y is independent value, right?
X is independent, Y is dependent. Because Y is dependent on X. Okay, Y is the price. Price is dependent on the number of homes, number of bedrooms, number of. So Y is dependent on these variables. So this is independent.
So doctor, when we predict the value, we are predicting the Y value depending on X.
Yes, true.
Yeah.
Okay. So they will give us the X and they will say what is the value of Y. So based on the independent values, X, so we have to tell the dependent or output values or target value, like price of the house or is the mail is spam or not. So based that will be the Y. Okay.
Yeah.
So this is the graph. It's again easy. So can you understand? Is okay?
Yeah, it's similar. It's similar to the previous one, but here we have another option is to draw a line.
True. So
and also we have a predictions. Yeah.
Yeah. So they are actually using the ridge kernel, ridge regression. This is a model which we will learn, and kernel he is using the polynomial kernel. This can be the linear kernel. If this will be the linear, then it would be the line. But in case of polynomial, it's like a little the verti, or you can say the curved line. It's curved, not line. So line is the straight line. Okay, so straight line, if we will apply the linear kernel, that is called linear regression. So linear regression will be the straight line. But if we have some other regression like multivariate, which is called polynomial, then polynomial means we will use more than one variable, then it can be the parabola, it can be any shape, okay, it can be any curve. So it no need straight line. So he is using to fit the values, he is using the polynomial kernel. So we will use these models, then you will learn more. Okay, so it's using the rich kernel, and from the sklearn, again the same library, scikit-learn, and he's using numpy as his give the np name, and numpy is numerical Python for the like different purpose, like he is just using for the making some values and he want to save it in array or whatever. Okay, so these are the, so these two lines like model kernel reach, model dot fit, he is training here, and prediction model dot predict. Model dot predict means he is applying on the testing data set. Model dot fit, he is training the data set based on the training data. So based on these three lines, he is doing all the things. So this is called supervised learning algorithm. So other is just a visualization to show how good the line is given. So
But doctor, I have a question, please. What is alpha? Alpha equal 1. What is this?
this one?
Yes, also on the previous one, there's alpha 1.
Where is alpha?
Yes, with
Here?
in the first model equal Karen
This one?
Bridge. Yes, what does alpha mean?
Normally alpha is like the learning rate, you know, but here I have to check what he actually used alpha here, because normally this is the constant value also given here, you know, mx plus c. So we have to check what will be the constant value, but here I have to check what he is using here as an alpha, because I have to read the documentation of the rich kernel, because it's just a name
Yes.
he has given, but I have to check what he is using alpha here. So this could be the little different. I will check and then I will let you.
Okay.
So yeah, other is simple. We have just used matplotlib and we are just plotting all the things the same way as previously. Then is applications of supervised learning. Many of the most important applications of machine learning are supervised, like classifying medical images, like we know if the tumor or not and where is the tumor, and translating between pairs of languages, like if we want to translate English to Arabic and Arabic to English, something like this. So how we can do this? This is again a supervised learning algorithm we will apply. Detecting objects in self-driving car, like we have to find what is in front of the car. It's some car, it's some person, it's some tree or some dog. So all the detecting the objects is again the machine learning task, which we will do some supervised learning. Okay.
Yes.
So I think we can stop here.
Okay.
Yeah, I have given 3 lectures already, so even in university and in other guys, so for now it's okay.
Thank you, doctor, so much. Thanks for your time. I understand. Thank you.
Okay,
No, I hope our doctor explain as you explain. The lecture used not to explain in details, so I have a lot of things I did not understand as a doctor, but with you, it's very simple now.
Yeah, normally it takes time to learn, but with the time, hopefully, you will learn more things.
Yeah, thank you so much. So, doctor, in computer vision, I have a problem. Last time, our doctor gave us a quiz, and the doctor said by using a Gaussian filter, and he gave me the values of the image, and he gave me a specific. He specified the center of the image. Okay, so we have to apply a Gaussian filter into it. I did just only for the center. I apply the filter just only to the center as it's in a question, but I don't know in which time I can use. There's 2 kind of filters. If I have 1-dimensional and if I have a 3+3 matrices. So if you can help me, I can just pay for you another money to explain for me these. Okay.
Okay. So whatever you want to learn, maybe you can also send me the computer vision lecture. and then
Mhm.
I can also just go through one time and then I can explain.
You know, doctor, the lectures, it's more easy, not like this using PowerPoint. It's very simple from our doctor. So I may send you, but now I'm focusing on machine learning, maybe next week,
Mhm.
because our exam is next Thursday.
Okay.
Yeah, so before that, I can schedule with you.
Mhm.
But the machine learning is on Tuesday, on Tuesday.
Yeah, I think till Saturday, because we have today is Wednesday. Yeah, Wednesday. So Thursday, Friday,
Yeah.
Saturday. I think in next 3 days your work will complete. So did you get more lectures or no? Only 3 lectures you have.
What?
So
No, the doctor said we've been taking linear regression, logistic regression, and also the third one. But the doctor said no, we have to just only linear regression and logistic regression. I think only 2 lectures.
Mhm. So whatever the
Yeah.
data you will get from the professor, the teacher, then you can send it to me, like about computer vision or machine learning. So then whenever you want to learn, you can just let me know about the lecture number and the subject, then I can explain it. Okay.
Okay, thank you so much, doctor.
Okay, great. Okay.
Yeah, have a
God
good day.
bless.
So
Yeah,
we'll complete tomorrow. Yeah,
sure.
goodbye.